Okay, so as we just wrote in that first one, we're going to remember, okay, that a square root and a squared power undo each other. Okay, so for example, what we wrote above, we said that 2 squared was equal to 4. Well, that means that if I wanted to take the square root of 4, that would be taking the square root of 2 squared. And so just like up above, the radical and the exponent undo each other, and I'm left with just that 2. So the idea is going to be, okay, that when I go ahead and I take these square roots, that I'm undoing the power, okay, the square power that's underneath it. So if I asked for the square root, let's say of 25, that's asking for the square root. 25 is really 5 squared. So the root and the power undo each other, and I'm left with just that 5, which again, some of you very well might already know all of this, right? If I wanted the square root of, let's say, 100, well, that's the square root of 10 squared, right? Root, power, they're the same, so they're going to go away. I'm left with what's underneath the radical. Okay, now again, if I do a much larger one, let's suppose I do the square root of, let's say, 1600. Well, I would want to write that, okay, again, I want it as something squared, so that should be a 40. So square root of 40 squared. And so I'm left with just 40. Now, if you're not sure, you're always welcome to punch it on your calculators. So remember that on the calculator, you're looking for, regardless of which calculator you have, and I do apologize, I don't have a red one here with me at home. But regardless of the calculator that you're looking for, you're always looking for that squared key, and above it should be the radical. So remember to find that. That's the second key, and then the radical key, and then it'll show up. And so if I wanted the square root of 1600, I can always punch that on my calculator. Okay, so you can absolutely check them that way. Now, the trick is going to be that sometimes, as we go forward in this, the radicals don't reduce nicely, right? I don't get an integer value. So again, if I punch, like if I look at G here, and we go ahead and we punch the square root of 18, well, the square root of 18, I'm sorry, let me change that, right? That's not a nice number. That's that decimal. They go on forever and ever. In fact, if you remember your algebra, this is the irrational, doesn't repeat, doesn't end, it's going to go on forever. Okay, well, sometimes it's not good enough to leave it as a rounded form. And so you'll hear them say something about exact form. And exact form just means that we're going to leave that radical in there. We're going to pull out as many perfect squares as we can and leave the rest under the radical. Okay, so remember that when we say perfect squares, that's what we all wrote just in example 1. So we're looking for 1s, 4, 9, 16, 25, all that good stuff. So as I look at 18 down here, the question to myself is, are there any perfect squares that could multiply, or in this case divide, like that I could get a factor of to get to an 18? So I can find 18 with a 1 and an 18. That doesn't work. 3 and 6, but those aren't perfect squares. But 2 and 9 are. So if I rewrite 18 as the square root of 9 times the square root of 2, very similar to what we were doing above. I'm going to go one step further. This 9 I could write as the square root of 3 squared. That 2 doesn't have anything to offer though. Now what we just talked about is if I can get a radical and a power that's the same thing, so a square root and a squared power, those are going to cancel. I'm left with what's underneath, so I'm going to get a 3 on the outside and a square root of 2 on the inside. This is what we call exact form. Okay, so not a decimal. I'm going to leave it as exact form. So let's go ahead if we look at example H over here. So 20. Lots of ways to get a 20. Okay, so to get a 20, I could do 1 and 20. Neither of those are perfect squares. I could do 2 and 10. But again, I didn't write any of those numbers down up at the top either, right? Those are not perfect squares either. I could do 4 and 5. Well, 4 and 5, 4 is a perfect square. So this is the combination that I want to use. So over here on H, we're going to go ahead, sorry, let me switch colors so you don't get them confused. H, I'm going to go ahead and I'm going to rewrite this as the square root of 4 times the square root of 5. Now 4 can be rewritten, that's why we picked it. 4 can be written as 2 squared, which means I can use the root and the exponent to undo each other, So what's underneath is now going to be outside my radical. The 5 is going to stay where it was. And so the square root of 20, its best answer in exact form, is 2 square roots of 5. Let's go ahead and look at I. I'm going to move the paper here. So as you look at I, okay, again, I'm trying to think of all the ways to get to 75, and I really want to do it, okay, with a perfect square. So as I think about 75, I'm going to immediately think of quarters, okay? So 75 could be the same thing. I could rewrite this as the square root of 25 and the square root of 3. 25 is a perfect square. So I can rewrite this as 5 squared times the square root of 3. The radical and the power go away, and I'm left with just what's underneath. So that 5 is going to be on the outside, and the square root of 3 is going to stay on the inside. So my best answer in exact form is going to be 5 square roots of 3. Notice that this is all connected with multiplication. Okay, so I don't have a plus sign out in front here. It's all going to be multiplication. All right, we look at example J yet. So 300, again, I think the first thing that comes to mind for me, lots of ways to get 300, but again, we're trying to find that perfect square. So how about if we use 103? Okay, now 100 could be rewritten as 10 squared and the square root of 3. These guys are going to cancel. So 10 is going to be on the outside, and square root of 3 is what's left over. So again, I'm going to read that as 10 square roots of 3. All of these answers are what we call exact form. So no decimals. I want to leave them in exact form. That's going to be our idea here.